Okay. What I'm going to do is go over go over COM+ services at a fairly high level. I want to make sure that we drill down into the vision of COM+ and what our guiding principles are, so you can understand really what we're trying to accomplish. I'm not going to be showing any code. I'm not going to be running any demos. I'm just going to be talking about it as sort of a high level, so you understand what we're doing. I figure that when you actually get the bits in your hand is when you'll actually go out and figure out what the APIs are called and what all the switches and the decorations are for your objects. So I'm going to go through the goals and the philosophies, and I'm going to give a very high-level architecture picture over how we're actually implementing this. It might help you understand how we're putting these things together. And then we're going to talk about some of the very broad-level features that are in COM+ 1.0. And then I'll give you a brief snapshot of where we are in the development cycle, and give you some dates and give you some ideas of where you can pick the stuff up. We'll talk very briefly about some futures, and I'll be real candid where we are on those futures when we get there. Then we'll summarize it and open it up for questions. So, the talk itself is about an hour long. Depending on how many questions we have, we could, I think this is scheduled for 2 hours, so we can go talk for 2 hours if that's what you want. So you're really in control of how long this talk goes. So the goals and philosophies for COM+ 1.0. What we're trying to do is to make Windows the best platform to develop, deploy, and maintain component-based applications while leveraging your current investment in Microsoft technologies. Now that's a pretty long vision statement. Basically what that boils down to is we want to make Windows 2000 the best application server in the world. We want to make it really easy for you to design your applications, to write your applications, to deploy your applications, and when they're deployed, we want to make it really easy to maintain that. And that's a pretty broad statement, a pretty big statement, and we're going to be focusing on what I call the abilities. Usability. Make sure that it's easy to use. We want to have a very simple programming model so that it's very simple for you to conceptually design your applications and to get your components to play in your application and in this architecture. Scalability. We want to make sure that that COM+ applications, the COM+ works very well at the low end and also at the very high end. So there's no real difference in how you design your applications from the low end to the high end. We're not there yet, but that's the goal. That's what we're trying to do. Maintainability. We're trying to make this. We're trying to make these COM+ applications that you'll be writing, your customers will be writing, very easy to maintain. It's all based on a component-based architecture with attribute-based programming, very simple, and we're going to make it easier for you to monitor your running application so you can figure out what's going on, so you can figure out where the hot spots are and drill down from there. And again, availability. We're putting in more features to allow you to put together an environment that has higher availability than you'd have now. We're also taking advantage of all the things that are being done in Windows 2000 for availability. Okay, so what is COM+? Well, COM+ is a component object model, or an object model, with a bunch of services. So the object model that we're built around is, of course, COM, the component object model. It's the world's most successful object model right now, and will continue to be so if we have anything to do with that. And we're enhancing COM with a set of services. So these are common services that people need to write their enterprise applications, so that people can concentrate on writing their own business logic, and they don't have to spend time writing infrastructure or other common services. And again, we're trying to put this into an easy-to-use, easy-to-deploy, and easy-to-maintain model. So in a nutshell, that's what COM+ is. Now, I said COM was the most successful object model in the world. These are some of the numbers that back it up. It's a very mature object model. We've been shipping it since 1991. I was a little surprised when I saw that date, but that was when the first Olay objects actually were shipped. It's running on 150 million or more desktops right now. we're actually running at higher than 150 million. It's just, I don't know what that number is. So this was the last number about 2 years ago that we calculated. And basically all of the major applications at Microsoft are using that. NT, or Windows 2000 now. Office, Windows 95, Windows 98, Visual Studio, SQL Server, basically all of the major applications at Microsoft are built using COM or have COM components in them. It's a very successful, very thriving marketplace. It's, according to Giga, which is an analyst firm, it's over $670 million market, and that's excluding Microsoft. So these are people doing ActiveX controls. These are people writing COM-based tools, languages that support COM. So it's a very successful, very thriving object market. Now, COM Plus is a set of services for COM-based applications. And the way we have architected this is that you have a component, you have an object. Pretty much the only thing you have to do to be an object or a component is to support IUnknown. Of course, it's a little bit more complicated than that, but it's in general, it's a very simple thing to do, and you have this object. Now, what we do with COM Plus is we allow that object to participate in services. So to figure out what services we need to invoke, we have this thing called a context. So every object will have a context, and it's in that context that we figure out if we're going to be using transactional services, or if we're going to be using load balancing, or if we're going to be using queued components, or whatever. All that information is in the context. Now you set that context with what we call an attribute-based programming model. So the goal is just for it to be a check-off or a check type of programming model, where you say, yes, I'm transactional, yes, I'm a queued component, or no, I'm not. It's just a binary thing, yes, no, yes, no. So a very simple model, and the context really describes what services the component will participate in. So what happens is a client will make a call to an object, and we have this concept called interceptors that will pick up that call, and it will check the context before it comes into the object and as it leaves to figure out what services it has to invoke. So the first time in, we intercept the call, then we look in the context and say, okay, this is a transactional thing. If there's a transaction there, we're going to join it, and these are the attributes of that transaction. And then we'll actually pass the call over into the component, it'll execute, and when we're done, on the way out, again, we intercept that call, we look in the context and figure out what kind of cleanup stuff we have to do. So what that does is that all of the infrastructure is keyed off the context, and there's nothing that you have to do from a business logic standpoint to take advantage of these services. Now, this is the model that we're moving to. This is our architecture. Not all of the services work exactly this way, but this is the way we're going. Now, the benefits. The first benefit, of course, is simplification through reduction. Now, this isn't, what we're doing is we're providing more services through an attribute-based model rather than a straight API model. So this means there are fewer APIs for you to use, fewer APIs for you to remember, fewer APIs for you to look at. It's just attribute-based type of programming. We have another goal of zero plumbing. We want to take all the infrastructure out of your code. Let the customers concentrate on building their business logic. They shouldn't have to worry about transactional stuff. We really want to lower the bar for how much you have to know about the infrastructure to get your enterprise application to run. We're pushing a very simple, very scalable programming model. The component should, our client should create an object, use it, and release it right away. We don't want the objects hanging around, people holding on to objects. That leads to scalability issues. And we want to move a model to where the clients don't do much work at all. We want the servers to do all of the work. So you create the object, let them do the work, and then release it. It's a very simple and extensible architecture with these interceptors. we just look into the context and do what we have to do. We'll be putting more and more information into the context so that as we come up with new services, they'll just flow into the context and everything will be great. Another thing we're looking at doing is opening up that context interface and the interceptors interface so that customers can add their own services. Something we're not quite prepared to do right now, but it's something we're looking hard at doing for next time. Another way to look at this is that we are the glue in Windows DNA. What I mean by that is we're the thing that holds everything together, no matter what type of model you're using, whether you're using whatever language you want to use. We're pretty much language agnostic. We don't care if you're using Visual Basic. We don't care if you're using Visual C++. We don't care if you're using Visual Java. As a matter of fact, if you can figure out how to write a COM component in COBOL, we'll work with that, because all components are going to have this context. You can use the services if you're using active server pages, or if you're actually writing components itself. If you're writing online applications or disconnected or offline applications, you can use COM services. Centralized or distributed applications, we really don't care. Web or client-server based, it's the same object model, the same service model, no matter how you're architecting your platform. So the major features that are in COM+ are servers, transactions, security, administration, load balancing, queued components, events, and an in-memory database. Now, if you're out there and you're familiar with MTS, Microsoft Transaction Server, you'll recognize the services of servers, transactions, security, and administration. If you're trying to figure out how COM+ fits in with Microsoft Transaction Server, it's a real simple story. What we've done internally is we have merged the COM team with the MTS team, and so we have a tighter integration between our component model and our services that we're providing for these components. So those two teams merged together is the COM+ team. Okay? We've also have a well, I'll get to the other parts of the team later in the talk. So these are the 8 basic functions functionality we are providing for COM+ 1.0, and we're going to drill down into each one of them a bit. Again, I want to encourage you to ask any questions, sending them to count99@microsoft.com. It's going to be a real short talk if we don't get too many questions. Okay, so again, going back to the theme of making it simple, 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 or easier, 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 it is fairly difficult to write a server as compared to writing a client application. Server applications are a little harder to write. You have a lot more things to consider. You have a lot of threading issues. You have a lot of threading options. Threading, the bar is much higher for understanding threading if you're writing server versus client applications. Concurrency is another thing that you have to worry about. Concurrency as far as transactions go. You don't want to have too many people talking to too many things at the same time, or talking to the same thing at the same time. Process management, you have to figure out what's in what process. You have to set up a process for your server to run in. That process has to hang around. These are things that you have to worry about. N-tier complexity. Client-server applications, the industry's pretty much figured out how to write client-server applications. Writing N-tier applications are a little bit harder. How do you split things up? Do you have to worry about one server calling another? All of these are server issues that you have to deal with. Deployment of N-tier applications, again, is harder. How do I deploy my server? I know how to write a client application. Now how do I write it here and go deploy it over there? So all these things are harder to do. So with COM+, we try to make this easier. And I think we've done a pretty good job of that. What we tell people to do is to design their component like it's a client application. Single user application, single thread, no concern for your process. You write your components in any language that you want to, whether it be Visual Basic, Visual Java, Visual C++, COBOL, Fortran, whatever. You write your components in that language. And then you just, you do the equivalent of dragging these components into a package or into an application, and then COM+ takes care of making that a server and allow you to deploy it to another machine. So again, to summarize, you write your components as if they're single-user, single-threaded things, you drag them into a package, and you deploy that package as a server. So we've made that a lot easier. Handling failures. Okay, now you're away from this client server or this client-based application, and all of a sudden you have this distributed application where you have something on one system is dependent on another system, is dependent on some logic on another system, and it's all and the question is, well, if there's a failure, how do you handle that failure? It's always been a difficult problem. It's always going to be sort of a logical problem on how to solve these things. And you've got to handle failures in different systems. The failures can happen in your logic, they can happen on the database side, they can happen in some sort of interoperability scenario. Maybe you're using Unix or IBM transactions. You have to be able to handle failures anywhere in the system and have your application recover from those and do the right thing so that you can continue on. So what COM+ is bringing to you is a set of transaction services. We allow you to set transactional attributes on your components, or you can actually put make the calls inside of your components. You can mark the components as transaction required or requires new, so that if your component gets invoked, the interceptor looks into the context, it said, requires a new transaction, it'll set up a new transaction for you. It could say, it can join in an existing transaction if that's the way you want it to work, or it can run outside of a transaction if that's what you want. We have made some improvements over MTS. You can now mark your components as autocomplete or auto-abort. So just by default, when you leave your object, we can either abort the transaction or complete the transaction. Or you could, of course, put the code, the logic in there for to call set complete or set abort, whatever you want to do. We're also bringing something in COM+, something new to the table. It's called a Compensating Resource Manager, or CRM. And what that is a common logging facility and a common way or a framework for you to describe what your transactional action is, what your abort logic is, and what your commit or your complete logic is, so that you can have a very easy framework for adding, say, your logic into a transaction, or you can write a little transaction coordinator, say, between SAP transactions and your logic transactions, or whatever you want. So you can, an example of this would be if part of your business logic were to delete a file, the unit of work, the definition would be perhaps to take that file and move it over to some sort of junk directory. Your abort logic would be to take it back from that junk directory and put it back where you found it. And your set complete logic would be to actually delete it out of that junk folder. So now you have a way of participating in transactions without writing a complete resource dispenser. We've also done a lot of work with interoperability with transactions. We have worked very closely with Oracle and IBM and a number of different database vendors to get a common understanding of what XA is. XA is a standard brought forth by a group called XOpen that it's a standard for how pretty much for two-phase commit. What we found last year or the year before when we started integrating or trying to get Oracle transactions to participate with MTS transaction through XA, well, everybody had a different opinion of how XA was supposed to work. So we took a very pragmatic approach to that. We invited the Oracle people up and the IBM people up and just went through the spec and drove home a common understanding of what XA is, and we're sharing that understanding with other people who want to participate in COM+ transactions. Another thing we've been very, very active on is something called TIP, which is a Transaction Internet Protocol. It's a proposed standard. and we're behind it, pushing it. A number of other vendors are, and it's basically a way of receiving transaction. Well, how should I say this? Well, I'll say something that's not 100% correct just to get the point across. It's a way of receiving requests for transactions over the internet. That combined with something else that we're doing that's new called BYOT, or Bring Your Own Transactions. That's the way you can really get integration between transaction management. What BYOT is a set of interfaces that can be stuck on top of COMPLUS and also on the bottom of COMPLUS. And if you have other transaction monitors that will support these interfaces, then a COMPLUS transaction can enlist in, say, a BEA transaction, or the other way around. A BEA transaction could enlist in a COMPLUS transaction. So we have a really good interop story there with a combination of XA, TIP, and BYOT from a COMPLUS standpoint. Now also I do want to mention another product we have out there called COMTI, or Com Transaction Integrator. This is a group that has worked closely with the COMPLUS team, and what they do is they provide transactional interop with IBM, both IMS type transactions and also CICS transactions. If you don't know about this and you're worried about integration with legacy systems, it's a really cool technology to look at. There's no footprint on the mainframe. It's all handled from the Windows side, and it just goes right in through LU62 Sync Level 2, I believe. I know they were working on expanding the protocol that they were going to support, but it just comes in like it's a regular user, and it's just magic. It's a really cool technology. Now, another problem that people have is setting up security models for their applications, especially now that you're moving into web-based application. There are hundreds of users and many different systems and many different portions of systems. You got to get all the security all lined up so everything works right, and it's a very difficult thing to do. And what we've done is we've done a lot of work in COMPLUS on its role-based security model. So what you do is you define a role. So you say a typical user would be able to do A and B and C, but not D, but they can do F. And you can have another set of roles where you can't do A, B, or C, but you can do D and F. And you set up these roles, and then you can attach users to those roles. So conceptually, it's a very simple thing. We handle a lot of the security system mismatches underneath the covers for you, so that we do take advantage of NT security and other types of security systems that are out there, and everything just works. We've also given you the ability to assign security at the method level, not just at the component level. So that was a feature that was requested by many groups at Microsoft as well as customers, and we're delivering that in COMPLUS 1.0. Another thing that is key to understanding how COMPLUS works, and it's something I actually should have been talking about back in with the architecture picture, and that is the context flows from one object to another object. So if you have one component that creates another component, that context will just flow to that next component. So it'll just, all the transactional information is in there, all the security information is in there, everything just flows. Now, of course, we do give you the option of resetting some of that context if you don't want it to flow, but by default it will flow. And all of the information, the security information, is available in that context. So you can walk up to this, the security context, the security stack, and walk up and you can find out who, A called B called C, and you can find out the security settings of any of those other components, provided you have the permissions to do that. And all of this is, it sounds very abstract. That's because it is abstract. We've abstracted it out a lot to make the model very simple for the users and for the developers to understand, and we've pushed the complexity really into the infrastructure and allow the security administrator to handle all the security stuff, because that's what they do. Any questions coming in yet that are?
Well, one of the things is where the NetShow slides are.
Oh, I can answer.
So we can.
Okay.
We're at, if you just want to repeat this, it's at itiweb/count99.
Okay, the slides are at itiweb/count99.
One was real-world examples of LCE.
Okay, real-world examples of LCE. Okay, we'll get to that when we drill down into LCE. Okay, ComPlus plans for NT4. We'll get to that later. Okay, so there hasn't been any questions on what I've said to date. Okay. Management problem we have with most people have with distributed application is that management of these applications is difficult. It's conceptually harder than doing centralized application administration. How do you handle hundreds or thousands of clients? How do you handle tens or hundreds or even thousands of servers? How do you monitor? It's very difficult to monitor the system activity when you're talking about systems, many systems for an application. And also, there is a problem that GUIs, or graphical user interfaces, are just too difficult to look at for large systems. Can you imagine an application that has 1,000 clients, 100 middle tier servers and 10 back-end servers, and you say, show me the system, and doing that graphically, that'll take many screens for you to go through. So GUIs are great for small, but not for big. What do we do? Well, we've done a lot of work in ComPlus administration to make it easier to administer these applications, and that's work that's going to continue on for many years, making it easier and easier. The ComPlus administrator is an MMC snap-in, so it's very easy to use. Administrators will just find it, it's just like the Explorer on how you navigate through it. It leverages NT's client management technologies especially for client downloads. We'll be using the zero administration, the technology coming out of the zero administration Windows efforts. Darwin, things like that. So you can deploy to thousands of clients just as you deploy other things through NT. We have scriptable interfaces. Our GUI is built on the admin interfaces, and we have an admin SDK. So if you find what we provide is not good enough for you, not specific enough for you, you can programmatically do all the administration through these sets of APIs. We've also done a lot of work with events, system events. We actually use LCE for this to log interesting things that are happening to your system, and you'll be able to look at that information and figure out what's going on. We're also working with third parties to do common reporting, common displays of this type of information. So the goal here is we're logging everything that's interesting, or we allow you to log everything that's interesting, and you can go to third parties to have that displayed the way you want it displayed. Problem, how do you work when the servers are unavailable or when you are disconnected? Or how do you smooth the load put on a system? If you have a scenario that somebody was talking to me about before was racetrack betting. You take all the bets during whatever time you take bets, and then you figure out the payoffs, all at the same time. So as soon as the race is over, all the requests go in of, what did I win? What was the thing? And you just get this tremendous load on the system. So how do you kind of smooth that load out? Those are the types of problems people are having. They're having to write different types of components for a connected application versus a disconnected application. They find that very difficult to do. A lot of the sharing of the code doesn't happen. Deployment of two applications, one for a connected application, disconnected application is too much for some groups to handle, or it's not really too much for some groups to handle. They would rather not have to deploy two applications to do the same thing. There's also no way right now in an MTS application to really govern the system load onto that server. And what we're finding is a smooth ramp up of a scaling of, if you want to scale your system, it's harder to ramp up smoothly without some way of governing the load on the system. So what we did was we came up with something that called queued components, and this is really a simple way of looking at it is making DCOM calls instead of over a wire over a queue. That's not exactly how it works, but that's the way. That's an easy way to think about it. The way it does work is the client is written just to make calls as if it's making it straight to the server, and if you're using queued components, or if you've configured it using queued components, the call doesn't actually make it all the way to the server. It goes to something that we call the recorder, and it sits there and it just takes all the input, and it looks at the queue. Right now we run on top of Microsoft Message Queue. If the queue is up and running, the recorder will go ahead and send those messages off to the queue. If the queue is not up, it'll sit there and buffer these requests so that when the queue does come up, it can actually communicate to the server with fewer trips. When the queue is up, it takes all those requests and sending them, instead of to the server, it'll actually send them to a player, and the player will unpack all these requests and send them off to the server. So the cool thing about this is that client code and that server code are written the same way, whether it's connected or not. It's not exactly true. Our programming model doesn't allow you to do output parameters or in-out parameters. It frankly wouldn't make sense if you don't know if you're connected or not. You don't want your applications to wait for a response. So as long as you stay away from the in-out and the out parameters, you can write your applications the same way. And then it just becomes a runtime configuration issue whether you're going to be running over a queue or not. Now you can use MSMQ as a kind of throttle on your system. You can let only so many things go by. You can take full advantage of MSMQ on these things. And what we find is that people actually are writing connected and disconnected applications, and they are using this as something to smooth out the load. This is one thing that Netscape does with Kiva. This is a big selling point for them. They come in over queues, so they use that as a way to throttle the system load. Another problem people have is there's a lot of, they were forced to write their own eventing system. An eventing system is pretty much publish and subscribe. What that means is, as a subscriber, I want to know when something interesting happens. So when interesting thing happens, please tell me. And as a publisher, it says, well, I do interesting things, so when I do some of these things, I want to raise a flag and tell people that something interesting has happened. Now, of course, larger applications, even some smaller applications, have to put this type of functionality into their application. And since we didn't provide anything, they're off doing their own proprietary thing, or there's many third parties that try to tie these things together. And these things all work, but the customer that has to design their own, then has to build their own, then has to maintain it forever, and that's something that they don't really want to do. Another problem that they have is as they start connecting different applications together, they find that these proprietary event services that they have don't really talk to each other. So we're always re-architecting the eventing services to allow a broader reach. So what we're doing to relieve this problem is we're coming up with COM+ event services. And it's a very simple publish and subscribe model. It's late bound, meaning that when the event is raised, that's when we figure out who the subscribers are. And the notifications are just sent by ComCalls. So here's a diagram. I hope you can see it here. We have an administrator will actually, through an admin tool, go into the event database, and it will set up all of the subscribers, who's interested in what events. So when something happens, somebody will publish, or a publisher will fire off an event. Through interceptors, the event services picks it up. Actually, that's not true. There's a call directly to it. The event services picks it up, looks into the event database, figures out who it has to notify, and then it makes a COM call to all of the subscribers that have registered for the event. Now, when I say a COM call, that is a very important thing to pick up on. It could be in process, it could be out of process, it could be an async call, it could be a call over a queue to a queued component. There's a number of ways of doing that. So that way, if it's over a queued component, you don't have to. If the subscriber's down, they'll still get notified as soon as they come back up. So we have a question there that I see. Future of async.
Asynchronous?
Asynchronous COM calls. Okay. With ComPlus version 1, we are providing asynchronous COM functionality from an eventing service. That call out could be asynchronous. Without any follow-up on that question, I'm not really sure what I'm answering, but yeah, async is there. Again, the COM team and the MTS team merge together so we can get tighter integration. So, the async stuff will play in this picture. Another problem people have is when they start scaling their applications, they look at two things: re-architecting their applications to get it to scale better, or throwing hardware at the problem. And what we're seeing, of course, is even server hardware is coming way down in price. I was just looking at a dual proc 450 machine for, I think it was $700 with 128 megs of memory. So these things are really coming down in price, and people just want to plug in another system and just have their stuff scale. They run out of something, they don't want to re-architect. Hardware's too cheap. So they want to distribute the load across systems with no changes in the application, and that's no changes to the server application and definitely no changes to the client application. They also want to do this in such a way that they increase availability. So if a server goes down, things continue to run. So what we're doing to address this, or to start to address this, is using load balancing in ComPlus. Now again, a key thing to this is it's completely invisible to the client. The way it works is a client makes a call to a server, but because of some administrative setting, it doesn't actually go to the server, it goes to the router. And the router will look into something that we're calling a response time tracker to figure out what server to send it to. So it'll send it to the most likely least loaded system at the time. So it'll make the call to the server for it, and then it'll connect the server to the client. So for the remainder of that unit of work or whatever, you'll maintain that client talking directly to that server. But there's nothing that the client has to do. This is all set up administratively. Now, one thing that we are looking at doing next time is open up those interfaces to the response time tracker, so you can write your own little load balancing algorithm there. You can make it round robin, you can make it random, you can make it dependent on some data that you have, for data dependent routing. So these are the things that we're providing in. We're just doing the response time tracker right now in ComPlus. The way that's drawn there, it looks like the router could be a single point of failure, which would be bad for the availability portion of that. But that router could easily be configured on a cluster so that you can have the failover capabilities there. So did we cover everything there? Yeah.
ComPlus for MT4.
Okay, complex. Let's. Okay, we'll get to the complex on MT4 stuff in just a few slides when we start talking about futures, which is just a few slides here. Okay, another problem people have is they want very fast data lookups. This is when they don't want to go to all the way to the disk through database, say, to get their information. They need the stuff in memory. They need it cached. They need it blazingly fast. And it's difficult to write and maintain your own cache-based system. There's a lot of concurrency issues you have to deal with. It's not an easy thing to do. Also, some customers are saying that even the buffering, the memory buffering that some databases do, such as SQL Server, Oracle, things like that, are still not fast enough because they are out-of-process calls. So they want basically an in-proc data cache at the server level for many clients to share, and they don't want to grow their own. So what we've done is we've brought into Complus a technology called IMDB, or in-memory database. And what that is in-process, or access to in-process cached data. You can load the tables into IMDB either at startup, or you can do it based on an event or some other way. You just load a table into IMDB. IMDB is an OLADB data source, which means you can walk up to it and talk to it with ADO or the OLADB interfaces. Since it is in memory, how big it can be is actually constrained by how much memory you have. But we do the transparent 64-bit memory access. So if you're running on a 64-bit machine, which is alpha right now, but Intel in the future, it'll just run with the 64-bit extended memory. Otherwise, it's if you're running a 32-bit machine, you've got the 32 bits. It is transactional, so if you're doing operations against your in-memory database, it'll automatically enlist in a Complus transaction. It has a sophisticated lock manager, so that your clients can you have many clients sharing the in-memory database through the server, and again, it's all done through the. It can all be done through the COM Explorer. So this is something that can be done administratively. Since you are walking up to it with ADO, it just looks like a regular data source to your application.
David, I have a question going back to events. Is there a way to integrate or to interrogate a publisher on the fly in code to determine what events they support?
Okay, so the question is there a way to interrogate a publisher to see what they're going to publish, or what they can publish? Is
what events they support?
What events they support. Okay. No, there's no way of doing that I can think of. The way it works is in the code that you write, you raise the event, and the event service takes hold and looks into the database to figure out who the subscribers are. I don't believe there's a way. I don't know, if you could just take that, whoever asked that question, if you could just send it to D. Cameron, I'll go look at that. I can't remember the layout of the event database.
I have one more question going back to administrative tools. What administrative tool will be used to update or manage the router and response time tracker?
What administrative tools would be used to update and manage the response time tracker?
Right.
Okay, to update the response time tracker, that is just taken care of for you. There's nothing you have to do. We get the information directly from the system, and we monitor. We monitor how long it took things to come back, so we basically know the response time, and we update that very frequently. So there's nothing that you can do there. The router and the load balancing is completely set up through the administrator. Okay, so you pick the application that you want to load balance, and you pick the machines that you're going to load balance it against, and you pick the machine where the router will be installed. So the whole load balancing thing is set up through the administrator. And again, you can do it through the COM administrator that we ship, or the APIs are there if you want to do it programmatically. Okay. So where are we? Common questions that we have with IMDb. We'll see if we can preempt some of these questions. Is that yes, it is a writable data source. Writes are slower than writing directly to the database that's in the back end, or the data source that's in the back end. If you remember, you've got the data source that actually gets loaded into IMDb. So if you do a write, we actually hold on to that request for the write until we know that the write happens before we release it. We don't allow people to come in to the data source and update it while there is an in-memory database, while the in-memory database is being used. We don't allow people to come in and change the data there, because we don't automatically propagate it yet. So then, as far as performance goes, we've seen, twice as fast, 10 times as fast, 100 times as fast on reads. It is very fast for reading data. Okay, now, where are we and what are we shipping on, right now, today? Okay, we are part of Windows 2000, which is the new name for NT5. We are part of the operating system, so you can just, we're an operating system component. We will just be there. You can just depend on the stuff being there. All of the existing COM objects become COM plus objects, in that they will all have context available to them. If you're not using the context, of course, the context is logically empty and won't be adding any overhead to invoking objects or not. We distinguish between objects with context and objects without context, or without useful context. All MTS applications, when you install Windows 2000, will just become COM plus applications. There's nothing you have to do. Things will just continue to work. As far as how we're shipping, if you have Beta 2, NT5 Beta 2 right now, the COM plus functionality is in what's called the preview folder. So if you go to the CD, look in the preview folder, there'll be the installation for COM plus. Starting with Beta 3, which is fairly soon. I don't want to give the dates right away, but we're already working on RC0, so you can, it's a big project, so I don't know exactly when it's going to ship. There's dates, but I'll let you look them up. We're part of the base install, so if you install, Windows 2000 Beta 3, you get COM plus. Now the question of what are our COM plus plans for NT4? Very difficult question. We have stated in the past that we are going to migrate some of this technology to NT4. We have, since we've been part of the operating system, we've got a number of internal dependencies on us, so that if we go back and put this stuff into NT4 without the cooperation of these other groups, we will end up breaking their stuff and breaking applications. So when we went into the operating system, it became a little more complicated. We're still looking at that, but at this time I can't commit to it, and I would hold off on making any plans based on COM plus on NT4. We might get there, but it's going to take quite an effort by a number of teams to actually get there.
Is there any, one of the things that customers would really like is load balancing on NT4. Is there a way to address just load balancing for NT4?
Okay, so the question was, is there a way to address just load balancing or certain features in NT4? And I guess technically we might be able to do that. It is part of, COM Plus is a real good motivator to get people to upgrade to NT5. We're wrestling. I mean, you can tell by the way I'm talking here. We're really wrestling with it. There's a lot of people who really want to do this, and there's a lot of people who are not as anxious as we are to backport these things. So again, I don't have any definitive news there. The final decision hasn't really been made. So I guess that's where we'll have to leave it. Let me see. I'm looking over at the questions that we can put up there. A real-world example of LCE, loosely coupled events. One real-world example is something that we are putting into COM Plus, and that is system events. When something happens that's of interest in COM Plus, we do fire off an event, and we log that into our monitoring database. So that's one thing. It's basically when something interesting happens that other people need to be aware of. We've written some demos where let's see, how did the LCE stuff work? Okay, I make a queued component call to do something, and because we don't allow out parameters, you don't really know when it happens. You continue to work. It is transactional. You know the message is going to be delivered, but you never know when that happens. So a lot of times we fire an event back that's saying, "Yep, got the message. Yep, we did it. We're all set." So there's another example of events. Okay, I think that's all the questions on the board. So we'll continue. If you have any other questions, count99@microsoft.com. Okay, futures. As you can tell from our vision statements or our guiding principles, is that we're trying to make this simple, and make Windows 2000 the best application server in the world. And that effort is going to be many years in coming. We'll be offering more and more services. We're just going to continue to make things simpler. One thing that we are going to be doing in the next release is we're going to be beefing up the COM Plus runtime. MTS has had a runtime for forever, and we need to make that more efficient. We need to be put more stuff in there, so we'll just be beefing that up. We're trying to do a tighter integration with Visual Studio. A lot of people have said that it's very hard to debug distributed applications, so we're working with the VB team and the VJ team to get distributed debugging in there. Made a lot of progress there. We've got a lot more work to do there. Continued improvement of administration. Our goal for administration is to make administering distributed apps as easy as it is centralized apps, and through the great people we have working on this stuff to make it just brain dead simple to administer these things. We're also considering a number of new features. Two of note are object persistence. That's something we're looking at for the next version of COM Plus. Another one is something called component workflow. It's also called component scheduling. It's called a number of things, but it's basically a way to string together a bunch of components and guarantee a flow from A to B to C, and do that kind of administratively. So it's most people think of workflow as flowing information from person to person to person. This would be flowing things from component to component to component. Okay, summary and then questions. Make Windows 2000 the best application server in the world. Been over that a few times. Leverage existing customer investments. If you have invested in, no matter what language you've invested in, VC, VB, VJ, we want to be able to use your stuff. If you've already invested in COM, that's a good thing. We'll be able to, things will just run. If you've invested in transaction server, that's a good thing. Things will just run. Another way of looking at this ease of use is we want to combine the ease of client development. Remember, single user, single threaded, very easy programming model, with the power of the enterprise. We want to take advantage of those big systems. We want to take advantage of load balancing, take advantage of multi-threaded operations, concurrency, concurrency, the whole ball of wax there. But we want to keep it easy. And we're doing this by tightly integrating the component model with the services, and the key to that is the context and the interceptors. And as I said before as I showed before in the architecture picture, the way that works, it's a very extensible architecture, so we'll be able to add more and more services through that. Okay, well that was actually pretty quick. Open it up for questions. Again, count99@microsoft.com.
I have a question here. When do you use stored procedures versus optimized data access components in the middle tier?
Excellent question. When do you use stored procedures versus data access components in the middle tier? That is really, that's a question that gets asked a lot, and unfortunately the answer is it's going to depend on your application. That's one of the things we recommend benchmarking for if performance is your goal. Another thing to look at, though, is as you move things out of the database, things get a little more flexible. And I'm not saying that, I mean, if it's the right thing to do, it depends on your application, but things do get a little more flexible. You're bringing your transactions out a little bit more, so things can flow a little bit differently. Also, if your data access stuff, you could switch databases, although that's more theory than practice. People don't really switch their databases that often. So bringing the business logic of your stored procedure out is usually a good idea as far as component reuse and flexibility. Doing the data access piece is something that fits into our model a little bit better, but it's usually a performance reason that people keep it inside the database. So